Hello, and welcome to Chapter 15, the last homework video. We're going to go through these, and hopefully we don't have as many errors as we did in Chapter 13 and 14. I think the most problem was algorithmic with those Excels trying to do regression. Now, if you watched the lecture, hopefully you still have your Excel table, or the little Excel document I used for the practice problems, because we're going to kind of try to use it as we go through here. So, we have the following hypotheses are given. We have our pi. It's going to be less than or equal to 0.75, or the alternative is greater than 0.75. Sample of 130 observations revealed that there's a probability of 0.89. And we're looking at the 0.10 significant level. Okay. So the first thing that we have to do on our calculator to find z, since we're doing a one-tailed test, because we have the greater than and less than, take 0.5 minus 0.1. This will give us 0.4. Next, we gotta go to our table right here, Z table, and I know it's still pretty colors from past problems, but we're really going to look for the number that's closest to 0.4. So, and we find it right here, 0.3997, which makes our Z statistic 1.28. 0.28. Check to see if we're correct. We are. Next, we're going to compute the test statistic. Now, on your PowerPoint, this is this formula right here. Notice that it has probability minus pi, so forth and so on. If you take your practice problem 1, which is right here, you would probably have this one sample still up here. I went ahead and added what if we had the probability as known. So instead of doing our division of success and observations, right here, sorry I can't zoom it in, so that's C1 divided by C2, I only have it going from C5, which is the probability. It's already been done. In fact, we could just basically take these two, make this equal that if we wanted to, but that's a little bit more if we don't know one problem. So, using our chart, we do not have any successes that we know of. That's unknown, so I'm going to put 0 there just to let me know. We had 130 observations. Our pi is going to be 0.75. And then probability is 0.89. So this is going to tell us our Z statistic is 3.686 or 3.6869 since it's 2 decimal places. Let's check. We are correct. Okay, so what does that tell us to do with the null? Well, it failed our test. We're going to reject because it is greater than Z, or our critical value. Okay, so that's one. Yay! Again, formulas, if you program them to Excel, at least from the lecture, you will be able to knock out some of these probably relatively quickly. We'll see. Alright. Chicken Delights claims that 92% of its orders are delivered within 10 minutes of the time order it's placed. A sample of 85 orders revealed that 74 were delivered within the promised time. At the 0.05 significant level, can we conclude that less than 92% of the orders are delivered in less than 10 minutes? Okay. So, with this, again, calculator, since we're looking at less than, this immediately tells me another one-tailed test. So again, take 0.5 minus 0.05. We come out to 0.45. That's what we're going to look on our z-chart. So 0.45. What's closest to it? Right here. So it's 1.64. So I put a negative in front. The negative is reason because we're looking at less than. So we're going to be looking at a lower limit. So check is correct. Next, we're going to try and compute the test statistic. This time, we actually know what the sample size is. So we had 85 orders, 74 were delivered within the promised time. Okay. So 74, 85, and pi now is 0.92. So we're looking at a negative, turn this to 0 so we're not paying attention to that high number, a negative 1.68. Huh. Now we do know that the calculation was correct in the way that it was reading. So we're going to go ahead and do it again, but this time with each of its parts. Because who knows what's going on? So here's our value, our formula. I'm going to set the formula up here. We're going to put Excel and see if it calculates the same way. Okay. So our probability is equal to 74 divided by 85, which again, both formulas calculate correctly. So this is equals to 0.87. So there may be a rounding issue. Minus 0.92. Okay, there's our top. Next, our square root of 0.92 multiply by 1 minus 0.92. So we want to put that in parentheses. So notice that I'm typing in the numbers this time. We want to see if there was an actual transfer issue. Divided by n, which is 85. Okay, enter. So negative 0.05 divided by 0.02943. So this one actually comes out to negative 1.69, so almost negative 1.70. Alright, so even though my Excel was calculating it more correctly because it wasn't using rounding, apparently it was more acceptable to the rounding. So we do know that was a rounding issue. So if it does get wrong, you may have to piece it out, the formula, just to see where it's coming if we decide to round. I don't like that, but I mean, that's how it goes. Sometimes that's just really how it goes. Okay. So what is your decision regarding the null hypothesis? Probably going to reject. Why? Because z is less than negative 1.64. So you are going to reject. So I like that they try and throw us a loop and a trick. But we fixed it. Now, that's different between the regression of 13 and 14, which, again, that hurt us a little bit. But if this is a later class than these videos, yeah, you probably don't have to worry about it. Anyway, the Damien family owns a large grape vineyard in western New York along Lake Erie. The grapevines must be sprayed at the beginning of the growing season to protect against various insects and diseases. 2 new insecticides have just been put on market. Pyranon 5 and Action. Test the effectiveness of the 3 long rows were selected and sprayed with each of these chemicals. Okay. And it gives us the results. At the 0.01 significant level, can we conclude that there is a difference in the proportion of vines infested using Pyranon 5 as opposed to Action? Hint, for the calculations, assume Pyranon 5 is as the first sample. Okay. So, select the decision rule. Notice that we got 2 Z's, because we really do have an equal. We have a two-tail. So, since we have a two-tail, we have to watch out. That 0.01 might get divided by 2 to be 0.005. So, let's see. So, for us, again, 0.5 minus 0.005 is 0.495. Make sure to check my history. Yeah. Alright, so, Z-table. We're going to look for the 495. Getting close. Right here. 2.57. So, negative 2.57 and positive 2.57. Check. Okay, good to go. Compute the pool proportion. Yeah, y'all like going, uh-oh. Yes. But, coming to save the day is our Excel. Because there's our two-tail. So, sample 1. Number of observations, 425 with 40. Sample 2, 410 with 26. Okay, so again, if you're going from the PowerPoint, zoom out just a little bit. We did the pool, and you do the 2 sample test of proportions. Okay? So these two I've already programmed into this information to help me calculate the z-test. Okay? So all it is inputting into the formulas. So my pool is 0.07904. It's going to calculate for me. Let's make sure. There it is. Because again, we may hit rounding issues because mine's more exact than the actual McGraw-Hill. So value of the test statistic is 1.64. Good. And we are not going to reject. So do not reject. Reason why is that it is less than that 2.57. Okay, that was 3. Again, a little bit easier once we have Excel able to calculate for us. If not, again, you're going to have to put in the formulas from the PowerPoint into Excel. So I would suggest, again, to look at how I did it for the lecture video. But, again, for my z-test, notice that I separated these main ones down here at the bottom, so I can make an easier formula for the z-test, where I just took the proportions of 1 minus 2 and equal into the square root of f7 plus f8. Okay, next. The null hypothesis and the alternative hypothesis are as follows. The frequencies are equal. The frequencies are not equal. State the decision rule using the 0.05 significant level. Reject null if chi-square, and so forth. So we're going to have to figure out chi-squared. So remember, degrees of freedom is, again, k minus 1. So basically, how many categories we got? Minus 1. So 4 minus 1 is 3. Next, we go to the chi table. So past the F distribution, and here's chi. Notice there's only one table compared to the F distribution. And we're going to be looking at, we'll put it as green, get rid of this one, and this one. We are looking at 0.505, not 0.01, so remove. So 0.05, 3. So 7.815. Check. We are correct. Okay, so chi-square. Next, we're going to compute. So, is it already in this? Well, find cell. Here's our chi. Now, remember, there is an expected. Let's see how this was reading. We're looking at equal. So this is computed out as so. So we may have to modify what's in Excel, but we're also still using the table. So let's put in our frequencies. 30, 20, 20, 30. We are not using these two, so they're going to be removed. Okay. Here, since we only have 1, 2, 3, 4, we're going to change this to, whatever that is, divide by 4. I'll make sure it always comes up to that. So that later on it can calculate a little bit better. There we go. All right. So here's my observations. Here's my expected. Remember, we have to take observations minus our expectation. Then we have to square it. And then we divide it by our expectation. Okay, then add it all together. Which is actually pretty funny for this one. We'll have to say that. That's pretty crazy. So we're looking at 4. Okay. So what is our decision? Well, 4 is less than, so we're not going to reject. And the frequencies are equal, because they really did come out all equal. That's cool. And that's the first time we've ever had that happen in a lecture or in this. And this is the first time we saw that question. All right. So 5. The safety director of a large steel mill samples at random from company records of minor work-related accidents and classifies them according to the time that the accidents took place. Okay. Using the goodness of fit test and the 0.101 levels of significance, determine whether the accidents are evenly distributed throughout the day. Okay. Goodness of fit. So, first thing that we have to do is, again, figure out chi-square. So it looks like we got 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1 is 7. So we're going to go look up chi-square at the 0.01 and 7, which happens to be right here, 18.475. Okay, check. That is correct. Next, we're going to compute. So, let's go ahead and click the Excel data. Let's see what we got here. So really all that the Excel data gives is the times and the number of accidents. So we're going to go look up goodness of fit on here, see if it changes from the equal. So this does change because it is proportion. Is it? Or is it equal? This is equal. So, didn't really give us frequencies. So we're going to assume that they are done evenly through. So they are equal. So we're again using the same table. Yay! Okay, but we have 8, so we're going to have to insert a few. Of course, all of them went and did that. We'll get to that. We'll fix that a little bit later. Let's make sure we got all of our numbers. So 10, 7, 8, 22, 8, 8, 6, 17. Okay. This is going to equal to be 11 divided by 8. Copy. Okay. Next. Paste, 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 paste. Then drag down to replace the formulas. And we're looking at 20.98. Oh, it wants 3 decimal places. So 977. Check. We are correct. So our decision is to reject the null. Why am I rejecting? Because it is indeed greater. So there is evidence, sufficient evidence to conclude that accidents are not evenly distributed. Okay, so that was 5. So far, again, if you have Excel set up, they make it just a tad bit easier than doing all the calculations, just a slight modification. Alright, television viewing habits are changing, and they have all this, and they actually show proportions. So using the information in the top 4 choices, we have 38% viewers would keep Netflix. That's probably changed by now. 20% would keep CBS, 21% would keep ABC, and 21% would keep NBC. And then we have our random sample of how many viewers and who would keep what. Okay. So first off, we're going to select the null hypothesis and alternative. So for this, we have 2 keywords. One is saying stated and one is saying equal. Well, because they're proportioned, as you see, 38%, 20% so far, that is a stated. So, the proportions are as stated or as not as stated. Remember, alternative is always the negative. It's not. Okay. So, again, let's find the decision rule. How many do we have? We have 1, 2, 3, 4. So 4 minus 1, that's 3. On our chart, we have 3 at the 0.05 again. So 7.815. Again, you check. Always make sure you check to get the right critical value. Now we're going to calculate. Alright. So, notice that I have equal and an unequal. So, here's my unequal. Notice that I have proportions now. And our observations and our expectation. The only thing that's going to end up happening, our expectation, is whatever the proportion is, times our observation. Then we do the same thing. FO, our observation minus FE, then square it, then divide by FE, total it up, and there's our chi. So here, we need to input what we got. So, we have 0.38, 0.38 for Netflix. Notice that they changed the numbers too. Netflix is now the last one instead of the first. I don't know why they did that, just to mess with y'all, I guess. So, 32. Then we have 20 we keep with CBS, and that was 30 out of the sample. ABC, 21% would have kept. But observation for ABC was 26 and 0.21. Also would keep NBC. That was 32. Notice that they did say a random sample of 120. So if I keep this, lets me know that I did get all the numbers in there. We just make sure we match up to the proportion. So our chi, after everything calculates out, ends up being 7.416. Oh, and what's 4 decimals? So 7.4165. Okay, check. And we are correct. So again, are we going to reject or keep? We are going to not reject. Do not reject. And there's not a difference. Because again, we are less than our chi squared. So we can't reject the null. Yay. Question 7. The users of cell phones and automobiles have increased dramatically in the last few years. Of concern to traffic experts as well as to manufacturers of cell phones is the effect on accident rates. Is someone who is using a cell phone more likely to be involved in a traffic accident? What is your conclusion from the following sample information? Use the 0.05 significant level. Okay. So we're looking at had accidents last year, did not have accidents in the last year. So it looks like we have a contingency table. So again, we have 2. But this is indeed an contingency table. So we got number of rows and number of columns. So we have 1. So 2 minus 1. So 2 columns minus 1 is 1. 2 rows, 2 minus 1, because the degrees of freedom. So this was the fun one that I really couldn't really make a good Excel on. If y'all watched the lecture. I have no idea how it became negative. There we go. So, we do know degrees of freedom is 1. So again, on our chi, we're using 0.5 and we're using 1. So it is 3.841. Okay, check. It is correct. Alright, now compute value of chi squared. Alright, so this is the interesting one. Doesn't really use this table up here. So don't even worry about this table as of the meaning yet, because we have to figure out numbers and what we're expecting. So 1, we're going to delete that row because that row does not work for us. We're going to put in the numbers that we have because I need to see how it works. So we have 48, 64. And then we have 302 and 248. Okay. So, again, we're going to take 48. 48 is our first one. The row total for the 48 is 350. The column total is 112. So our formula to figure out what is expected is basically multiplying the row total multiplied by the column total divided by basically the sum of those two. So that means we expect to do 78.4. Okay. So again, this is going to calculate out. So we'll wait till which ones we're going to delete in just a sec. Next, we have the 302, because I'm going to go with the row. So still 350, except the column total is now 550. My grand total is not changing. That probably explains something there. Alright, just a sec. Yeah, for some reason it did not do grand total. I did not put in that formula. But it is the total of all of them. So it should be 662. Okay, so let's do 48 one more time. So 112, 350, 112. That's actually supposed to be 59.21. We're going to just round. Okay. Yeah. For some reason I didn't have that program and just had it entered. Okay, next. The 302. So, again, row total is 350. Bottom column is 550. So that actually comes out to 290.785. So again, I'm just going to do 2 decimal places. There we go. Okay, 64. Its row total is 312, column 12. So we're coming out to 52.79. if y'all can see what's happening already, it looks like definitely they're like almost equal to each other. Alright. So, last one. 248. Row total. 312. 550. Comes out to 259.22. And these two get deleted. So we have about a chi of 5.42. You don't need that. 421. Okay. 5.421. Okay, I may have rounded too much. If there wasn't one that stalled us. 259.215. And 290. And then last but not least, 312. So 5.424. There we go. So a little, yeah, if I didn't round, I would have had it in the first place. Yeah, it happens. So again, it is greater. So we are going to reject. And there is sufficient evidence that there is a change. Nice. Alright, question 8. There are 4 entrances to the Government Center building in downtown Philly. The building maintenance supervisor would like to know if the entrances are equally utilized. To investigate, 378 people were observed entering the building. The number using each entrance is reported below. At the 0.10 significant level, is there a difference in the 4 entrances? So this one, they actually want you to do the table, which is fine. So, again, we have the table already set up. We know they want an equal. We know it's shorter than what we have right now. So we have 88, 83, 103, 104. Okay, we want to delete these. Okay, and this is going to equal now to 4. So copy, paste up. Just wants to be that way. Okay, so there's our table already set up. We're good to go there. Let's go ahead and find our chi. So we have 4 minus 3, or minus 1, equals 3. So, oh, I'm just going everywhere. So 3, 7.815 again. Wait, we're at 0.1, sorry. 0.1, 62.251. Alright, degrees of freedom were 3. So you can double check on those. And then again, they want you to go ahead and put in the table, which we calculated already using our Excel. And they haven't changed main, broad, cherry, walnut. They're all the same. So we're going to go ahead and put it in. So 94.5. Negative 6.5. Okay, they're going to be 2 decimal places all the time. So 0.45. Broad was 83. 94.50. Okay, cherry 103. 94.50. Okay, 0.50. And 0.76. Walnut 104. And 0.96. Alright, then totals 378, 378. Real quick. 0. And since this is all rounded, we're going to actually put it in our calculator real quick, since we are dealing with rounded numbers. $3.57. Okay, check. See if they're happy. They are. And what are we going to do? Are we going to reject or keep? We are going to we're actually going do not reject. The null is not rejected. The entrances are equally preferred. Okay. Question 9. Okay. So, each of the digits in a raffle is thought to have the same chances of occurrence. The table shows the frequency of each digit for consecutive drawings in the California lottery. Form the chi-square at the 0.01 significant level. So we have 1, 2, 3, 4, 5 minus 1. That's 4. Again, click the wrong folder. Alright, so we're at 4. We're at the 0.01. So 4 is right there. Is a 13.277. Up. Digits. I just went with 4 rows. There's actually 9, so that's actually 8. This is what happens when you try and speed a little bit. Alright, so 8 at this is actually this one, 20.09. Okay, check to make sure. Oh, there's 10 numbers. Duh. I forgot the 0. So this is actually 9. Oh man, you can tell it's done. So 21.666. Oh, there we go. Oh, you can tell it's done. Okay, compute the value of chi-square. Again, we have the frequency of 10 numbers, but we have no proportions, and they're thinking that they basically get drawn most at the same time. So instead of doing the Excel and bringing in all the info, we're going to go ahead and add it. So insert, write another one. There we go. And we're going to put in the numbers. So 38, 33, 30, 43, 36, 36, 17, 41, and 16. We'll insert one more just to have a gap. So this is our average. So basically, this one's now going to equal to be 13 divided by 10. Copy. Paste, 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 paste. There we go. And we come out to 21.875. Okay, check. Again, most of the time, if you already got the table, the formulas in, with these chi-squares, it's just really reformatting. Or if you want to just download the Excel, you can, and then put in the formulas. Either way, it's perfectly fine. For me, I'm going to end up rejecting the null, barely. So, just barely. They're very close. And that's it for 9. 10. Last question. And so far, not really any problems except for a rounding issue in one of the early questions. Question 2. So, a sample of employees at a large chemical plant were asked to indicate a preference for one of 3 pension plans. The results are given in the following table. Does it seem that there is a relationship between the pension plan selected and the job classification of employees? Use the 0.02 significant level. Alright, notice we are again in a contingency table. Yay! So, we're going to reject each null. So see, we're at the 0.02, and we have 3, so 3 minus 1 is 2. But is that truly our degree? No. Unfortunately, it's not. I wish it was that easy, like everyone else. But once we recognize it's contingency, minus, it's going to be the rows. How many rows we got? We have 3. So 3 minus 1 is 2. Then we have 3 columns. 3 minus 1 is 2 also. So that means our actual degrees of freedom is 4. So table time. 4. And we're at, what significantly level? 0.02. First time I probably ever had that. So 11.668. And check. We are correct. Next, we're going to compute the value. So again, we're going to use our Excel. This time we've got an added column. So let's see if I can just insert one here. Okay. Actually, just delete that. Alright, so here we go. Let's go ahead and put in our table. So we have 35, 40, since we have 3 now, go ahead and change that. Then we have 30, 33, 66, and 34, 42, 48. So there's our numbers. Okay, so now that I know my rows and my columns and my grand total, it's time to figure this out. So we're going to take it each step by step. We're going to end up adding quite a few. So we're going to go ahead and insert. Alright, so starting off with 35. Their row total was 99. Column total was 110. So we expected it to be 30. Okay, 30. Notice I typically go through the rows. So you can do it either way that you like. I typically go rows. So 129 for the column, 35.1818. Next, 34. Its row, column is 124. So that is 33.8182. Next row, start with 35 again. This time, its row total is 110. Column 110. So 33.3333. Whoops. Put that in the wrong one. 33.3333. Okay. 33. Column total is 129. So this one is expected to be 39.0909. Alright, 42. Its column total was 124. So 37.5758. Next, last row. So we have 40. And their row total was 154. Column total was 110. 46.6667. $129. So we have 66. 54.7273. I want to insert one more for 48. And their column total was 124. Give me 52.6061. Notice that sometimes with Excel, if you insert after the last formula row that you did, insert the rows, it automatically copied the formula from previous one. It's always nice. So we're looking at 6 point, round to 3, 6.828. There we go. And what is my decision? Well, you all know I cannot reject. We failed to reject. And there is a relationship. Or there is no relationship, sorry. My bad. Alright. And that's it. That's it. You've completed all the homework videos. You are done with that part. And again, we didn't have to fix anything. Everything looks good. It just, again, if you have the Excel already pre-programmed, like from the lecture, followed what I did the practice problems, this homework is actually probably the easiest that we've had. So, if you have any questions, please let me know. And I just want to say, it was an honor to teach y'all throughout these homework videos. And hopefully they helped. Okay, y'all have a good one. Hope y'all have a great college career. And enjoy whatever futures y'all have.